Alright, and we've talked about how AI is transforming heavy equipment from dumb iron into intelligent machines. But let's get real. Talk is cheap. You want to see actual bulldozers and excavators operating themselves on real job sites, making real money, and proving this isn't science fiction anymore. Because here's the thing, while you've been wondering if this technology works, there are contractors right now who are running autonomous fleets that are outperforming human operators. And I'm not talking about some experimental test site in the middle of nowhere. I'm talking about active construction projects, mining operations, and solar farms across North America. So let's dive into the companies and projects that are actually doing this. Real machines, real projects, real ROI. And trust me, some of these numbers are going to blow your mind. First up, we've got Built Robotics out of San Francisco. These guys are the real deal. They've been retrofitting standard bulldozers and excavators with autonomy kits since around 2016. And by 2024, they were crushing it on solar farm projects in California's Central Valley. Now, solar farms are perfect for autonomous equipment. Why? Because you're doing repetitive grading and trenching over hundreds of acres. Same task over and over. This is where robots absolutely dominate humans. Here's what happened on one of their 2024 solar farm builds. Ready for this? Number 1. These autonomous dozers work 20-hour days, 4 hours for charging and maintenance, 20 hours of actual work. Try getting that out of a human crew. Number 2, they achieved roughly 30% more progress per week than a traditional crew. Not 5%, not 10%, 30%. And number 3, they did this with just one human safety steward on site who could take remote control if needed. But here's the kicker. They almost never had to intervene. The machines followed the digital terrain model with such accuracy that the humans were basically just babysitters. The project manager saw these results and immediately invested in more autonomy kits. Because when you can get 30% more work done with machines that operate 20 hours a day, that's not a competitive advantage. That's a demolition of your competition. Now, some of you are sitting there thinking, okay, Joel, that's great, but I can't afford to buy all new equipment just to get autonomous capabilities. And I hear you. Most contractors have existing fleets, machines they've already paid for, that still have years of life left in them. Enter AIM. Intelligent Machines, a Seattle area startup that just raised $50 million in funding in June 2025. Why? Because they figured out how to retrofit any bulldozer or excavator, regardless of make, model, size, or even age, into an autonomous machine. They use the same sensors that power self-driving cars, LiDAR, cameras, GPS, and attach them to your existing equipment. Then their edge computing system takes over the controls to dig, haul, plow, fill, and level ground without a human in the driver's seat. Now, here's what makes AIM different. They're focused on extreme working conditions, mining operations, remote sites, places where it's genuinely dangerous to have humans operating equipment. Their CEO, Adam Sadilek, said something I think is brilliant. Since the introduction of hydraulic machines like excavators in the 1800s, mining and construction have seen little of the automation that's transformed other industries. These are still among the most dangerous jobs in the world. And he's right. We've automated factories, warehouses, even some agriculture. But construction, we're still putting humans in harm's way on dangerous job sites. AIM is changing that. The autonomous construction equipment market expected to grow from $443 billion in 2024 to $986 billion by 2030. That's more than doubling in 6 years. This isn't a trend, people. This is a tidal wave. Alright, let's talk about Komatsu. If you're not familiar with them, they're a Japanese heavy equipment manufacturer that's been around since 1921, and they love precision engineering. Komatsu has been pioneering autonomous haul trucks and mining for years with their frontrunner AHS system. But what's really cool is how they've brought that technology to construction with their Intelligent Machine Control, or IMC, that automates blade movements on dozers and graders. Now, during COVID-19, when job sites were shutting down and crews couldn't work safely together, Komatsu had autonomous dozers in Japan preparing building pads with minimal operator input. Operators supervised from remote stations. This wasn't just a pandemic workaround. This proved invaluable in disaster zones where sending human crews was genuinely unsafe. Earthquake damage assessment, flood zones, contaminated sites, send in the robots. And here's the ROI. Komatsu reports that automation cut average earthwork times by 50% on certain smart construction pilot sites in Japan. 50%. You're getting the same job done in half the time. If you're a contractor and you're not paying attention to this technology, your competition is going to eat your lunch. Now, we can't talk about autonomous heavy equipment without mentioning the 800-pound gorilla in the room, Caterpillar. CAT has been developing autonomous technology for years in the mining sector, and in 2024 they deployed their first autonomous haul trucks in a North American quarry. This was Caterpillar's inaugural foray into self-driving machines for the construction aggregates industry. But here's what's really interesting about Caterpillar's approach. They're not just making machines autonomous, they're making them electric and autonomous. And at CES 2024 in Las Vegas, Caterpillar showcased a prototype battery electric 950 GC wheel loader. This is a 20-ton loader with a 256 kilowatt-hour battery that can fast charge using standard EV chargers, zero exhaust, much lower noise, same breakout force and performance as diesel. And CAT expects this to be in production by 2025, which, spoiler alert, we're already there. What Caterpillar is doing is leveraging their massive dealer network to pilot these technologies with customers right now. They're not waiting for the technology to be perfect. They're putting it in contractors' hands, getting feedback, iterating, improving. That's how you win in technology. You don't wait until it's perfect. You get it to 80%, you deploy it, you learn, you improve. And CAT gets this. Okay, last example. And this one is absolutely bonkers in scale. Liebherr, German-Swiss manufacturer known for gigantic mining and earth-moving machines, announced a deal in 2024 that should make every contractor sit up and pay attention. They signed a $2.8 billion deal with Fortescue Metals Group to develop and supply 475 zero-emission mining machines for Fortescue's operations in Australia. Let me repeat that. $2.8 billion. 475 machines. And these aren't just any machines. Around 360 autonomous battery electric haul trucks, 55 electric excavators, and 60 battery dozers. This is touted as one of the world's largest deployments of autonomous electric vehicles to date, and it's the largest equipment order in Liebherr's 75-year history. Now you might be thinking, Joel, that's mining, not construction. What does that have to do with me? Here's what. Mining is always the proving ground for construction equipment technology. Why? Because mining operations have the scale, the budget, and the engineering resources to test cutting-edge tech in the harshest conditions imaginable. If autonomous electric equipment can survive in remote Australian mines, operating 24/7 in extreme heat, dust, and brutal conditions, then it can absolutely handle your urban construction site or your suburban development project. So let's step back and look at the pattern here, because there is a pattern, and if you understand it, you'll understand where this technology is headed. Number one, this technology works right now, not in 5 years, not someday. Companies are deploying it today and seeing real ROI. Number two, it's being proven in the hardest conditions first. Remote mines, disaster zones, extreme weather. If it works there, it'll work anywhere. Number three, the economics are undeniable. 30% productivity gains, 50% time savings, 20-hour workdays. These aren't marginal improvements. These are game changers. And number 4, this is a tender billion market. By 2030, the money is flowing in. The big manufacturers are all in. This train is leaving the station. Now, I know some of you are still skeptical, and that's okay. Skepticism is healthy in this industry. We've seen a lot of revolutionary technologies come and go, but here's the difference. This time, the technology is ready. The economics work. The safety case is overwhelming. And most importantly, your competition is already implementing it. So the question isn't whether autonomous equipment is coming to construction. The question is, are you going to be an early adopter who gains competitive advantage? Or are you going to wait until everyone else has it and you're playing catch up? Just something to think about. Okay, let's continue. We've talked about autonomous equipment doing the work, but here's what a lot of people don't realize. The real money saver isn't just that these machines can drive themselves, it's that they're constantly learning how to be more efficient. And I'm talking about efficiency gains that can literally save you tens of thousands of dollars per machine per year. This is where machine learning comes in. And no, you don't need a PhD to understand this. Think of it this way. Imagine if every time your excavator operator made a dig, the machine remembered exactly how much fuel that dig consumed, how efficient the motion was, and whether there was a better way to do it. Then imagine it learning from millions of digs across thousands of machines worldwide, all feeding data back to improve performance. That's what's happening right now with modern construction equipment, and the results are honestly staggering. Let's start with fuel consumption, because fuel is probably your second or third biggest operating cost after labor. And here's a dirty little secret about construction equipment. We waste an ungodly amount of fuel through inefficiency. You know what the biggest fuel waster is on most job sites? Idling. Equipment sitting there, engine running, burning fuel, accomplishing nothing. Studies show that heavy equipment sits idle for 28 to 40% of its time on construction sites. Let that sink in. Almost half the time you're burning diesel and getting zero work done. Komatsu analyzed telematics data from approximately 75,000 machines over a year. You know what they found? Average idle time of 38% for their equipment in North America. Volvo Construction Equipment estimates that large construction fleets were talking about 450 machines on average that typically experience 28 to 30% idle time. Industry experts say to balance operational needs and minimize waste, idle time should ideally be kept below 20%. Most contractors, they're sitting at 30 to 40%. That's 10 to 20% of your fuel budget going straight out the exhaust pipe for nothing. Enter AI-driven fuel management systems. These systems use machine learning algorithms trained on massive data sets to do something traditional equipment can't. They learn the optimal way to operate based on millions of data points. Here's how it works. The system analyzes data from sensors all over the machine. Engine temperature, hydraulic pressure, load weight, terrain slope, operating speed, you name it. It's collecting thousands of data points per second. Then machine learning algorithms look at this data and identify patterns that correlate with high fuel consumption. For instance, it might discover that sudden accelerations burn 15% more fuel than gradual ramp-ups, or that operating the hydraulics at a specific RPM range is 20% more efficient, or that certain operators consistently use 25% more fuel than others doing the same tasks. But here's where it gets really cool. The system doesn't just identify problems, it predicts and prevents them. Let's say you're operating a bulldozer. Traditional equipment, you're making all the decisions. When to shift, what RPM to run, how to angle the blade, when to lift it. You're guessing based on experience and feel. With AI integrated equipment, the system is analyzing your terrain in real time through cameras and LiDAR. It knows you're about to hit a harder section of ground. It can automatically adjust engine, RPM, gear selection, and blade angle before you even realize you need to. The result? You're using exactly the amount of power needed, no more, no less. These systems can integrate directly with the vehicle's engine control unit to provide real-time gear shifting recommendations. Some systems even do it automatically. They're optimizing the driving patterns of different operators, resulting in improved fuel efficiency across your entire fleet. Companies using AI-driven fuel management are seeing reductions in fuel consumption of 15 to 30%. Think about that. If you're spending $100,000 per year on fuel, that's $15,000 to $30,000 back in your pocket per year. And all you had to do was let the machine learn how to be more efficient. Now let's talk about predictive maintenance, because this is where AI really saves you money. Traditional maintenance is reactive or scheduled. Either something breaks and you fix it, that's reactive, and it's expensive because now you have downtime, emergency repairs, and maybe a ruined project schedule. Or you do scheduled maintenance at predetermined intervals. Change the oil every 250 hours. Replace filters every 500 hours. Whatever the manual says. The problem with scheduled maintenance, sometimes you're replacing parts that still have life left in them, wasting money. Other times a part fails right before its scheduled replacement, and now you're dealing with a breakdown anyway. AI-powered predictive maintenance is different. It monitors equipment conditions in real time through sensors embedded throughout the machine. Temperature sensors, vibration sensors, pressure sensors, oil quality sensors, wear sensors, all feeding data continuously to machine learning algorithms. These algorithms are trained on historical data from thousands of machines. They know what normal operation looks like. They know what a bearing sounds like 100 hours before it fails. They know what oil degradation patterns predict an engine problem in 2 weeks. Caterpillar is all over this. In March 2025, CAT launched a fleet management solution with AI-enabled predictive maintenance that reduced unplanned downtime by 25% for rental fleets. 25%, that's a quarter of your unexpected breakdowns. Just gone. Caterpillar reports they have 300,000 connected machines worldwide. That's 300,000 machines all feeding data back, all learning, all getting smarter, and they're seeing double-digit productivity increases from this technology. Their VisionLink platform uses AI to analyze data from sensors on equipment. It can predict when equipment will fail, allowing for proactive maintenance scheduling before a breakdown occurs. It identifies patterns and anomalies that indicate potential issues. Abnormal temperature readings, unusual pressure spikes, increased vibrations that signal bearing wear. Then it recommends specific service actions to prevent unplanned breakdowns. Not maybe check this, but replace the hydraulic pump in the next 50 operating hours, or you will have a failure. This is huge for scheduling. Instead of a machine breaking down in the middle of a critical pour or earthwork operation, you can schedule maintenance during non-productive hours. Evening, weekends, between projects, you're maximizing equipment uptime and minimizing the impact of maintenance. Komatsu is doing the same thing with their Smart Construction Edge platform. In 2024, they incorporated artificial intelligence that can automatically remove obstacles, equipment, structures, whatever, from drone survey data. But they're also using AI across their equipment to optimize performance. Their Intelligent Machine Control, or IMC system, uses GPS and sensors to guide equipment with incredible accuracy. But it's also learning every pass of a dozer blade, every scoop of an excavator bucket. The system is collecting data on fuel consumption, cycle times, and efficiency. Over time, it builds a profile of optimal operation for different soil types, different grades, different weather conditions. Then it automatically adjusts machine parameters to operate at peak efficiency for those specific conditions. You're not just automating the work, you're optimizing it continuously. The results? Komatsu reports that automation cut average earthwork times by 50% on certain smart construction pilot sites in Japan, but they're also seeing fuel savings of 15 to 20% from optimized operation. Think about that for a second. Half the time to complete the job and using 15 less fuel while doing it. That's not incremental improvement. That's a complete transformation of how construction equipment operates. Now, some of you might be thinking, Joel, this all sounds great, but I'm not Caterpillar or Komatsu with thousands of machines. I've got 10 machines, maybe 20. Does this technology work for smaller fleets? Yes. Absolutely yes. Because here's the beauty of machine learning, Wire. You don't need to have 300,000 machines for your machines to benefit from that data, Wire. And when you buy modern equipment with AI capabilities, you're tapping into the collective learning of every machine that manufacturer has in the field. Your excavator learns from data collected from tens of thousands of other excavators. Your dozer benefits from patterns identified across hundreds of thousands of operating hours from machines all over the world. You get the benefit of massive scale machine learning without needing massive scale operations. There are also third-party telematics solutions that work across different equipment brands. Companies like Verizon Connect, Geotab Mixed Telematics, Samsara. They all offer AI-powered fleet management systems that work with pretty much any equipment you have. These systems track real-time location, usage data, fuel consumption, idle time, operator behavior, everything. Then machine learning algorithms analyze it all and give you actionable insights.
Your excavator operator number 3 idles 40% more than your average. Reducing his idle time to fleet average would save you $4,200 per year in fuel. Your dozer is showing vibration patterns consistent with track wear. Schedule maintenance in the next 2 weeks to avoid a breakdown. Your skid steer has been operating at 90% capacity for the last 3 hours. Recommend rotating equipment to prevent overheating and extend component life.
This is real intelligence delivered in real time, helping you make better decisions about equipment usage, maintenance, and operations. The construction equipment telematics market, that's the market for all these connected smart systems, was valued at $6.92 billion in 2024. It's expected to grow at 11.5% annually and reach $20.59 billion by 2034. Why? Because contractors who adopt this technology are crushing contractors who don't. They're getting more work done with less fuel, with less downtime, with better equipment life. The ROI is undeniable. Over-the-air updates like your phone gets are helping manufacturers deliver additional functionality without replacing hardware. This resulted in 15 to 20% reductions in annual maintenance expenditures. You're getting new features, improved efficiency, and better performance through software updates. Let me give you a specific example of how powerful this optimization can be. HD Hyundai unveiled an AI-powered excavator at CES 2024 in Las Vegas. This thing uses machine learning algorithms to optimize entire construction processes. It's not just optimizing individual movements, and it's optimizing the sequence of movements, the timing of operations, the coordination with other equipment. The AI analyzes the job site, understands the task, plans the most efficient sequence of operations, and executes it. It's like having a master equipment operator with 50 years of experience running every machine on your site. Research from Huazhong University of Science and Technology in China, working with Shantui, developed an autonomous bulldozer that operates in extreme temperatures as low as -10 degrees Celsius. The machine learning algorithms adjust operation parameters in real time based on temperature, ground conditions, and equipment performance. These aren't concepts, these aren't prototypes. These are deployed machines working on actual job sites right now. So, here's the bottom line on machine learning optimization. AI isn't just making equipment autonomous, it's making equipment smarter, more efficient, more productive, less wasteful. Every gallon of fuel saved is money in your pocket. Every hour of prevented downtime is another hour of production. Every optimized operation is a competitive advantage. And the best part, this technology is only getting better. Every day, millions of machines are collecting data, feeding it back to machine learning systems, and improving the algorithms. The equipment you buy today will literally get better over time through software updates and continuous learning. That's the power of machine learning in construction equipment. And if you're not paying attention to this, you're already behind.